Welcome back to Dev Radio. I'm here again with Wayne Meyer, part of our Cloud Adoption Framework series. And today we're talking with Brett and Shane, a couple of our global black belts who have built the Synapse Solution Accelerator to get you up and going with data warehousing and proof of concepts. And Wayne, why don't I turn it over to you? How are you doing?
Hey, I'm good, thanks. And it's always good to be back. Good to be with you. That jingle on this at the beginning kind of gets me wrapping my fingers every time. So it's kind of cool. It's cool to be here. I'm glad to see it. Yeah, it's kind of, I think as we've gone through this and we've built kind of this CAF series over the last year or so, I'm excited to see kind of some of the new things that are popping up all the time. You know, we've gone through this right at the start where we gave customers that early view into building out a strategy and a plan and kind of standing up your landing zone. And I think we've had a bunch of partners coming in doing some really cool kind of sessions as well. So I'd encourage you to go back and check out some of those. I think, you know, as we've kind of gone through this journey and we're at least like in this adoption phase of our journey, we've spoken a lot about templatizing different projects and making sure we kind of drive repeatability and kind of automate a bunch of the work that we're doing in the cloud. And I think, you know, when I came across Shane and Brett the other day, kind of, I think it was surfaced up in a meeting, who said, hey, we got this cool accelerator. I thought this would be a great place to kind of surface this up. And fortunately for us, they were kind of open to talking it through. You know, I think as we kind of look at the adoption framework and we look at some of the templates that we have built already in the, you know, that we've got these ADO templates as well as some of the solution accelerators that we've spoken about. I think these are just great ways for customers to be able to pick up some of these tools that we have and get going, you know, in a very rapid fire manner. And I think this particular scenario that Brett and Shane are going to kind of talk through today, I think is one that is top of mind for many. I recently just posted something on LinkedIn around the data platform landing zone that has been built out and it's part of the adoption framework. And I was kind of blown away about how many people actually engaged with that and kind of looked at that piece of content. So it's pretty topical. So I'm excited to kind of see, you know, what Shane and Brett are going to kind of walk through. You know, the repos are there. Feel free to kind of go and check out the links afterwards. We'll put them all into the comment section. As I say, this continues to be part of the adoption framework. Make sure that you have a plan, get your landing zone established, and then really kind of rapid fire kind of programs and projects that have been established to help get you up and going. I think is critical. So Shane, Brett, do you guys want to do a quick intro and then dive right in?
Awesome. Go ahead, Brett.
Sure. Yeah, I'm Brett Myers. I'm an architect on the global black belt team for data and AI at Microsoft. So we work with our most strategic customers deploying Synapse and big data solutions like Azure Databricks and HG Insight.
Awesome. So Shane O'Cotney, also an architect on our cloud data and AI team, and likewise work with many of our largest customers on their advanced analytics projects.
Cool.
Awesome. So I will share out my screen and talk through a few things. We'll have a few slides to walk through, and then we'll actually show some of the deployment itself. So first things we want to do is just level set a little bit on Synapse Analytics, because really it's a unified data platform with quite a bit of capabilities in big data, data warehousing, data integration. So we want to talk through that a little bit and then specifically where the accelerator fits in here. So there's multiple compute engines within Synapse Analytics. First two being dedicated and serverless SQL, which are really geared towards data warehouse type workloads. Dedicated where you explicitly allocate a predefined amount of compute for your workload, and serverless being where it's dynamically allocated for you, more of a pay per query kind of operation, and you're creating virtual lake databases on top of files that exist on the data lake instead of actually ingesting them. Next is the Spark engine, which is often used for large-scale ETL, data exploration, and data science development. There's also a fourth engine, Data Explorer, which is geared towards time series type data, such as logs, telemetry, IoT, and streaming data. And then there's a few integration points with some other data platform services, like Azure Machine Learning, where you can do auto ML on data sets that live inside of Synapse Analytics, or operationalize models that are inside of Azure ML on top of data sets that live inside of Synapse Analytics. There's Synapse Pipelines for orchestrating ETL type activities, bringing data in Synapse, moving it around and pushing it out. There's integration into Purview Data Catalog, such that data sets that are created inside of Synapse will be populated inside of Purview along with the lineage of how they became to be. And then there's integration into Power BI to make it easy for end users to actually access curated data sets that are created inside of Synapse Analytics. The Accelerator that we're talking about and showing is really focused on the dedicated and serverless aspects with the data warehousing in mind. That's one of the core use cases with Synapse, and that's kind of where we're focused on the Accelerator. So the Accelerator itself has really three facets to it. One is a proof of concept environment where you're deploying an environment. It's kind of an easy button to have all the best practices defined at the deployment time. The second are the deployment templates in the form of Bicep and Terraform. And then the third are some additional features and utilities that we included within the Accelerator. So the first aspect is the actual deployment of the POC environment. So we focused first and foremost on individuals that are very new to Synapse. They haven't used it before, or they haven't used it much. We focused on those and those that are looking to do a POC or test drive of a data warehouse type workload. There's a lot of best practices for Synapse, how to deploy, manage, monitor, tune. But to somebody that's never used Synapse before, it's a lot to consume and understand. So what we did was we took a lot of those best practices and we embedded them into this Accelerator so that they're there out of the box. And as soon as you deploy, those are defined, those are set. So the first thing I was going to show is really how you actually start the deployment, how you deploy your Synapse instance with all these best practices and what that looks like. So the template is designed to run in the Azure Cloud Shell. So there's nothing for you to download, install, configure on your computer. You can just do it all directly through the Azure Portal. So if I jump over to the Azure Portal, I have my main Azure Portal, and then I'm going to click the button to enter into the Azure Cloud Shell using Bash. And as soon as this loads, I'm going to do a git clone of my repository where the Accelerator lives. So I'll do git clone and paste the repository. So this will download everything there, create a folder for us, which I'll change directories into. And then the last thing I have to do is just execute the deployment script itself. So there's a few steps. Yeah.
Quick question. So once we've kind of run through this, what is it that as a newbie, what would I kind of be able to do at the end of this?
Yeah. So there's a few things. What's that?
In terms of the outcome.
Yeah. So there's a few things. So and I'll jump back a little bit as this starts to deploy. I'll jump back to my slides, right? So the outcome being that you can run a command and you have a fully functional Synapse environment with all the best practices applied to it, and then also some additional utilities to help with things like data ingestion, which Brett will kind of talk to and show in a little bit. So as this deploys right now, what's really happening is the deployment scripts deploying the Synapse Analytics workspace with some of those best practices. It's deploying a 1000 DWU dedicated SQL cluster, which is a reasonable size cluster for many of the types of data volumes that some of our customers are bringing. And we're doing things like enabling query result caching out of the box and querying store out of the box. We're also creating a data lake storage account with a landing zone and making sure proper permissions are set for you along with the Synapse Analytics workspace for you to bring your own data in and ingest it. And then finally, we're creating a log analytics workspace to where Synapse and Data Lake has its logging and telemetry configured to push into the log analytics workspace. We're also deploying a couple automatic data ingestion pipelines to make data ingestion very easy, along with using some best practices. Again, Brett will talk to that. And then within the advanced configuration of the templates, there's private networking or private endpoint feature flag that you can enable. And when you do that, the deployment will then create private endpoints for Synapse and the data lake for all the components. It'll automatically register the private endpoint DNS records with your Azure private DNS zones. And then it'll enable all of the firewall capabilities on the data lake and on Synapse, such that it only accepts connectivity from internal addresses.
That's a lot. Good job.
So that's the deployment aspect. The next I was going to talk about the actual deployment templates themselves. So certainly the templates are used in the Accelerator, right? That's how we're deploying the actual Synapse environment. But they're designed to be used outside of the Accelerator as well. We have customers that are doing infrastructure as code, they're doing CI/CD. They often come to us looking for guidance, help, suggestion, examples on how do I create Terraform templates for Synapse in it. So what we did is we created both Bicep and Terraform examples that can be used independent of the Accelerator, but they deploy the exact same environment with the exact same options. We just really wanted to meet customers with where they're at, right? A lot of customers use Terraform, that's fine. Everyone else uses Bicep, that's okay as well. So I'll jump over into VS Code where I have the repository open, and I'll just walk through some of the actual templates themselves so you can get a feel for how that works. So I have the repository open in VS Code. I have a few folders in here. The first one I'll start with is there's a folder for Terraform. In typical Terraform fashion, we have a terraform.tf vars file, which contains a lot of the default settings you might want to configure for the deployment itself. And then I also have my main.tf file, which is the configuration for the entire environment, Synapse, Data Lake, Log Analytics, all those best practice settings within here. And then as I scroll through some of this, what we did is we took the code blocks themselves for the different resources and configurations. We have code comments that describe what's happening. We have, for each code block, we have a link to the Azure documentation for that particular resource or configuration. And then we have a link to the Terraform documentation for that particular resource or configuration. So as I mentioned before, these can be run independently. So as a Terraform person, I can come into this directory, I can do my traditional Terraform init, plan and apply, and it will deploy the environment for me. And of course, I can just take this, use this as a reference, or use this elsewhere in my environment. Likewise, I have a folder for Bicep. Within here, I have my main.parameters.json file, which has those same default settings that we've seen in Terraform. And then I have my main.bicep file. And in here, the main.bicep file references the modules that we have created for Log Analytics, Data Lake Storage Account, and then Synapse Analytics. And likewise, if I come into one of these modules, these bicep files, the resource blocks code blocks that I have in here have the same code comments, have the same links to the relevant Azure documentation, and then have the links to the relevant Bicep documentation as well. And just like Terraform, as a Bicep user, I can come into this folder and just do a traditional AZ Bicep deployment and deploy it. So that's what I was going to cover just from the templating perspective, and then Brett was going to talk more on the additional features and utilities.
Just a quick question for you on the
Still there?
I'm still
Looks
here.
like we dropped Wayne for a minute. He'll be back, I'm sure. This happens sometimes. Do you want to just keep moving on to you, Brett? Looks like
Sure.
he's got network issues.
Sure, let me go ahead and share my screen here. Can you guys see my screen?
Yep.
Perfect. And so up to this point, what Shane just demonstrated is we're starting from square one, where we have nothing, and we've went ahead and ran these bicep or Terraform commands, and it populates or creates the Synapse workspace, the storage account, the log analytics workspace, etc. And so now we have this environment. It's configured. We have these features, turned on. And now we're ready to actually start using Synapse Analytics. What we've found is, to actually use Synapse Analytics, you need to have kind of a training. You need to have some experience with it. And so we thought, hey, we want customers to be able to use this awesome product and be able to query their data as fast as possible, without having to go through documentation and figure out best practices on how to load data. And so one of the features that we developed was the Parquet auto ingest pipeline. And so this gets deployed as part of that deployment. So when you run the commands and the workspace gets deployed, you get a few pipelines, and one of them is this Parquet auto ingest pipeline. And the purpose of this pipeline is really to define the location of your data, whether you copied it to the storage account that gets deployed as part of the workspace, or if you had the storage account in your own location and you configure the network activity to that storage account, we can also pull that data from there. And so it's a CSV metadata file that you go and update, and then you just give it the schema, the table. Some parameters if you want to specify the cluster, the index and the distribution of the table. So this is really to get data into that dedicated pool of compute, and so you can specify beforehand. Hey, I know this is a large table, and I know this is the column we want to distribute on. You can add that as part of the file, or you can leave it blank. And when you leave it blank, we'll actually profile the data and pick it'll profile the data and pick one of those attributes based off or columns based off the data that was returned. And so you essentially just, all you have to do is copy your data over that storage account, update and create update or create a new CSV metadata file and point the pipeline to that metadata file, and trigger the pipeline to start ingesting that data. And you just sit back, relax, enjoy a cup of coffee, wait until it completes, and then you can start using your data. Start running your queries on your newly created data or tables. And so to walk you through the process, first the pipeline's going to read the CSV, the metadata file that we define, and one gets deployed as part of the process as well. So you have one to look at, one to edit, to make changes, to create it from scratch. You can simply just copy and edit that file. So first we read that file in using actually the serverless engine to do that, read the data directly from the lake, so the CSV file. We then create the schema, so whatever schemas were specified in that metadata file, we create them on the pool. And then from there, we do a for each loop. And so this is at a per table level, and we run this in parallel. So we get, we're running, if you specify 5 tables, specify 100 tables, we're going to run those in parallel within the loop, the for each loop of the pipeline. And so once we do that, or we're in that loop, we're going to profile the data on the lake. So this is a lightweight profiling step that we actually use a serverless engine to do as well. And that's really to grab what columns exist in the Parquet file or files in that directory, and then profiles the data to say what's the data type that we should put use as we create that table in a dedicated pool. And the key component here is really strings, right? When you get to varchar and varchar, it could be the default is going to create 4,000 characters, and what this is going to do is it's going to do a max length to say, okay, actually the column only has 10 characters, so let's create that column in the table as 10 characters, and that really improves performance, query performance, especially when those columns are used in joins and where clauses, etc. And so we set the correct data types for the table and create the DDL to actually execute that. And then we go ahead, and the next step is to actually just execute the staging tables. So we define those staging tables using the profiling step that we did on the lake. And then we create them, and then we execute a copy command to ingest that data into those staging tables. And so that's the initial ingestion process. The next step is actually to create those destination tables. So that final landing area where we once again profile the stage data. And so this is where we do a pretty deep dive of the profiling. And so we grab things like per column, we grab the data type again, we grab the unique values of that column, the number of nulls in that column, the min, max, the length, the standard deviation, the average. All these we take into consideration when defining which column is optimal for the distribution, which column is optimal for the index. We grab row counts, we grab total table size, etc., and we log all this information. It's used as part of the rule engine that we developed to actually create the what we call CTAS statements, create table as select, which will then ingest that data or pull that data from those staging tables into that final destination where we specify the index and the distributions. After that step is complete, we then run statistics. So typically when you create a new table and you start querying that table, statistics are created on the first time you start querying it. And so we said, hey, let's just add this as part of the loading step. So as soon as the table is loaded, we just create statistics as part of that. So there's no extra step that once users are actually start querying this particular table, the statistics are then created in the background. It's like, let's just do it up front and get it out of the way. As statistics are very important, right? And then the last step is actually to trigger a table build. And so what that means is when a table is defined as a replicated table, as a distribution replicated, what that means is again, kind of that same scenario in the statistics creation is when a user first executes a select statement on that table, it will actually in the background trigger a build process. And so for those replicated table definitions, they're actually going to move that data from one node into all the nodes that are part of the cluster. And that can take some time. I mean, depending on the table size, et cetera, which part of the profiling step we've identified which tables should be replicated and which tables shouldn't, but there is still additional steps that has to complete for a query to actually even execute. And so that data has to get replicated first, and then the query runs. And so in this case, we're going to say, hey, as part of the loading process, again, let's just add it as part of it. And so to trigger that build process, so once this process is done, the user just starts running the queries, statistics are there, tables are built, everything's good to go. And then the final step is as we're running this whole process and ingesting the data, creating this staging tables, profiling data, et cetera, we log each step into logging tables. So as soon as you execute this pipeline, it's going to create these log tables for you and then track all those changes. So for example, hey, maybe the CTAS statement didn't create the table with the distribution that we would like, because based off query patterns, we think this other column would be a better fit. Well, all that information is logged for you, so you can just execute a select statement on the log table and grab the DDL and then change the one piece, the column name for the create table as select, and run it again, and you get your new table in the format that you want. So there's a level of customization that you can do after this process has completed. If we want to change tables around, alter the data types, etc., you have that ability. So to jump to show you what that pipeline actually looks like, first I'm going to jump to the Azure Portal, and here's a deployment that I did this morning. And so we created this is what got created as part of the Terraform and Bicep templates is the dedicated pool itself, the workspace, a storage account, and the log analytics workspace. And so if I jump to the Synapse workspace, you can see the pipeline here that I have open, the Parquet auto ingest, and then on the left, I'm going to expand the databases and just show, hey, the SQL data warehouse database got created, DW 1000 as part of the deployment, and there's no tables in there, right? And so we're going to go ahead and I'm going to jump to another tab. So I'm in the storage account now that got deployed, and we can look at the metadata file that's there. And so this is the Parquet auto ingestion metadata file. To take a look at a little better view, if you want to just see what this looks like in Excel. You can see we can specify the target schema name. So what's the ultimate table we want to land it in, the table name that we want to call it, and then define the distribution and the index for that target. So if we know beforehand that, hey, we want to skip that profiling step and just say, hey, we're going to hash on reseller key and make that a cluster column store index, you can specify it there and it'll skip that step and you'll get that extra boost in performance because we're not having to do that profiling step. But you can just leave them blank and it will do that profiling step and create the table that we see fit to eliminate skew, set the right resource class, etc. For you. So you don't have to worry about it. You can just leave it blank. And then the last piece that you have to provide is the folder path. And so in here you can see, here's the data lake that we're pulling from, the directory, and then we're pulling from all Parquet files. So we're using the wildcard to say, give me all Parquet files in this location. And so to jump over to the CSV here, I'm just going to go ahead and edit this one, right? We'll just come here, we'll add a new line, and we'll change the schema. We'll just say like Azure Dev Radio. And so what this is going to do is create a new table in schema Azure Dev Radio, using the same table that we had specified before, but the same folder path. But we'll just show you that, hey, this is going to create that table, how easy it is to update the metadata. And then we'll go ahead and trigger this pipeline. So you can come into the Parquet auto ingestion pipeline, do a debug. You can specify the metadata file. It's going to auto populate to the file that's already out there. But if you have multiple metadata files and you want to run this on a different file, you can specify it as one of the configurations or parameters that you pass. And so this is going to start executing. So it's grabbing runtime variables, creating the log table. So no tables existed as part of the load itself. And so if you don't want to use the Parquet auto ingest pipeline, you don't have to, and the database is going to be completely empty. And so everything's encapsulated as part of the pipeline itself, is creating the log files, running the SQL scripts, etc. Going to queue up and we'll start executing here. And so you can see the create log tables and then the get metadata. And then we're going to filter on the schema, loop through the schema. So if, in our case, we had a DBO and then an Azure schema. We'll then create each one of those schemas, and then we'll actually jump into that table loop.
Hey, Brett, sorry, I had an internet drop a short while ago.
Sure.
In your experience, kind of from a customer taking this and having to hand jam and build all of this stuff kind of by themselves, what is the typical kind of time frame that you've seen wanting to take this through?
Yeah, if they're starting from scratch, it can take a long time, and it depends on the number of tables you want to load and ingest. There are some nice features as part of the workspace itself. So once you establish this link service to your storage account, you can expand your storage account and query your data. So we have, for example, we'll just do the Parquet auto ingest metadata file. You can do a top 100 on this file, and this generates the syntax for you. So that's just a select statement. You can also do things for creating external tables. Again, it doesn't profile the data to give you the correct data types, etc. So it's always a step that you want to go through and make sure that maybe there's just a flag column that's a yes or no, and we're going to have a 4,000 length column here, so you can specify that. And so that's the tricky part. And so you can essentially build your tables from that, but it takes a lot of time. It can take a lot of time, especially if we're trying to do a migration and we just want to get 100 tables into your Synapse dedicated pool. You have to go through each one and create that. What this is going to do is just profile that data for you and create those data types, etc. And so you can see here it's executing. So we started executing the schema, creating the schema if it does exist, and now we're in the table loop. So you'll see a lot of activities going on down below as I hit refresh here. If we jump back over to the workspace and we can do a refresh on the tables, we can see where it's actually at as it's creating these tables. And so we were started at nothing, and now we have all these staging tables created for us. And if we look at the columns here, we can just actually that's not the logging one. We don't want to look at that one. One of these other columns here, and we can see the data types, et cetera, that were created as part of the process here. And so you can see, hey, of our char 12 versus the 4,000 that it would default to. And so we're setting the maximum string types, setting the integers, decimals, et cetera, for you. And so now we're it looks like we created a lot of those staging tables. And so we're copying that data using the copy command into the staging tables. And staging tables are round robin heaps. So that what round robin means is as the table is distributed in a round robin nature, the data is going to insert into each of the distributions in a round robin method. And so it's a way to get data into that table as fast as possible. And then we specify it as a heap. So there's no index on the table, again, just to get that data from the lake into the dedicated pool as fast as possible. And then if we hit refresh again, we should see some of these smaller dimensions start getting created. Yeah, so here we can see dim account is now there. And so if we just do an action and say, hey, let's do a top 100 on this count on this table, we see that data is now populated for us. So again, everything out of the box, you just say point to where my data exists, and it'll create those tables and schemas. And you can even see here's the Azure Dev Radio table that got created as part of the process. And so it's really as simple as that. Update the metadata and hit go. You don't need to have this additional knowledge on what's a distribution, what's an index. It's going to pick it based off this rule engine that we have that we see from our customers.
You guys have done such an awesome job here. I think as we think about customers wanting to, being able to go take this and utilize, a couple of questions. One is, have we done any kind of analysis to what it would cost for a basic kind of deployment of this? Because I know that's always a block. When you say to customers, you'll say, hey, here's a reference architecture. Next question is, okay, how much does it cost me to deploy? So do we have any kind of indication of what they need to go and budget for? And then secondly, going from POC, which we kind of got in the name, to production, how hard is that to kind of take that and productionize it?
So I'll start at the second one, the last one. And so to productionize this, and so this is really designed for accelerating your POC experience, taking you from 0 to 100 in a matter of minutes, an hour, depending on the data size that you have. And so once you have all the data structured, you'll want to go through and advance, do some additional tuning, hyper tune your model, et cetera. And depending on how the data landed in the data lake, if we're strictly going replicating, hey, we got an on-prem data mart that we want to move and look at it in Synapse very quickly, right? We can create all these tables. You can script the DDL out and then deploy to your production environment after you go through that hyper tuning process. And then back to the first one, as far as the cost. What would normally take days, weeks, potentially to get an environment stood up, it takes a matter of 5 to 10 minutes for those Terraform templates to actually deploy. And then as far as pricing wise, so it cuts the time by 1,000%, 100%, and getting all those configurations set and settings set for you. You also have the ability to scale down. So in some of the advanced features, you can specify the correct, the dedicated pool size that you want. We default it to 1,000 DWU. That tends to be a good middle ground on just demonstrating the performance of Synapse without having to break the bank. But you can easily scale up and down, and so it really depends on how much data you have, et cetera. And one actually additional feature that we didn't have in the slide deck that I just remembered is the auto pause and resume pipeline. And so what this pipeline does is it's going to actually, we can schedule a trigger to say, at 6 p.m. every day, we're going to pause the dedicated pool. And so, if going back to that first slide, the dedicated pool is a set of resources that you're charged for whenever that pool is on. But as soon as you pause that compute pool, you're no longer charged for it. And so, standard and POC and in dev environments, hey, we want the pool on during working hours, so 8 a.m. to 5 p.m. But after that, no one's on it. No one's on the pool. No one's running the queries. And so we want to save on costs during those off hours where developers aren't actually in there querying data. We added a pipeline that will simply trigger a pause, at 5 p.m., 6 p.m., whatever time you specify it as, to save on that additional compute cost, because that's really where the bulk of the charges will come from, is that compute charge as part of the dedicated pool. So it's another kind of cost saving metric that we cost saving measure that we implemented that we see common. Hey, we left the sink running over the weekend and we were charged for 2 days of compute that no one was actually doing it, using it at that time. And so another one of those, hey, we have this pipeline as part of the deployment. Specify the time you want the pool to pause and resume, and you're off to the races.
Yeah, I love that. I think, there's a couple of things that you just really hit on there, which is important, and obviously that ongoing optimization and being able to kind of build that into the process that we have for cloud, I think is hugely valuable. And then that time piece. Just the fact that you've been able to build this out in a couple of minutes whilst we've been on this call is significant. And it goes back to when we talk about customers standing up their cloud environments, and we've created reference architectures. We built them so that we can help accelerate these things, because many of the times customers are just in this world of having to hand jam and go through all the pain and trying to figure out how the things kind of connect together. 6 months down the line, you're still kind of messing about. So I think what you guys have done here is just phenomenal, and I think it's going to be a game changer for customers, just getting accelerated and kind of seeing things working.
Yeah. Something that would take days is now minutes, hours.
Yeah. Good job.
Yeah, thanks. So that's the auto ingestion for the dedicated pool. And so you can see here we loaded the whole AdventureWorks database that we have out there, plus that extra table into our dedicated pool. The next feature we want to talk about is something very similar to the Parquet auto loader, except this is the Lake database auto DDL creation. Follows very similar pattern as the dedicated pool side, but this is actually going to utilize that serverless engine. So that serverless engine is pay as you go, so pay per query. That reads data directly from the storage account or the data lake. And so with the serverless engine, you can do an open row set and read the CSV or Parquet files directly, or you can specify views. So the view would just be an open row set SQL statement with a view wrapped around it. And so it makes it easy for business users to say, query this view that the developer created for them and does some sort of transformations on the data. And then you also have the ability to create external tables on top of your data. So external tables and views in your Lake database. And so the process for this is the exact same. We're going to read that metadata file, create the schemas for you, and then profile the data, do that lightweight profiling of the data on the storage account, and then create the DDL for both the external table and the views, as well as the statistics for the external tables and statistics for the open row set. So again, one of those things that you would have to jump out to the documentation, I do at least, to remember what the syntax is for each one of these. Now we're going to create that for you with the correct data types and optimizations on those particular features, and then you can just open up the log tables and extract that data to run your artifacts. So if we want to look at that pipeline, this one's much faster and much easier as we're not actually ingesting data. We're just simply creating the DDL for the table for the data structure that's out on your lake. And again, this will create a separate logging table. So the dedicated pool has a profiling log table that you can we'll see here in a minute, as well as the logging table for each of the individual steps, creating the schema, creating the staging tables, doing the CTES statement, stats, etc. There's a separate logging table that will get created as part of the serverless that captures those additional SQL statements, like creating the external tables, creating the views, and so forth. So you can see here the logging step are about done with all our tables. There we go. And so now in our log tables, if we jump over to that, we'll go ahead and query the serverless just to show you what those look like. So I'm connected to the dedicated pool, the data warehouse, and I'm going to grab the latest pipeline run. And so this is what the log table was generated for us. We capture some useful information like pipeline run ID, pipeline name, and so forth. But scrolling over is really the meat of it, right? So we want to say, hey, what's the external table syntax for our dev radio table that we created? I just simply copy and paste that out, and then format the SQL string. And now all this syntax is generated for you to execute on your serverless pool, specifying the correct data types that were found in the data, and located at the right data location there. So you have to typically you have to create the file format, the data source, create the schema, then create the table, etc. I made this rerunnable, and so you can run this as many times as you want. So if we jump over to the on-demand, the serverless endpoint, we can go ahead and connect to the demo database and run this. And so no ingestion happens as part of the serverless. We just specified what does that data look like. So we can now just do a select. We'll do a select top 100 from this table. And this created the external table as part of the in our demo data lake database. So you can see that the data is there without any extra stuff. This is used as serverless query, pay as you go method. To jump over to the other log tables, just to show you some of the information that gets stored. So if we look at the auto ingestion, just to show you what kind of information that we capture, you can see here, all the steps that occurred, what was actually occurring, creating the table, creating the staging table, and then the SQL command as part of that. So you can copy and paste, for example, and then format it to see exactly what was used as part of the deployment. And so if you want to create a new table, you can just simply update the statement and run it yourself if you want to go a manual method. And so when we start talking about, okay, we want to move this to production, well, guess what? We've already logged the DDL statements to do this. And so you could just capture directly from the log table and use it as your migration to your production environment. And then just to show you one of the more important ones is the create table, CTAS final table, as this is the one that really depends on user query patterns. And so depending on what the distribution is, and then what indexing is used. And so for example, in this statement, the dim currency table, because it's so small, it's going to get a distribution of a replicate, and then it's going to be a heap. And so that's just so small of a table that we determined that is the optimal configuration for that table. And so you have this ability to say, hey, you know what? I don't want to make this replicated. I want to make this hash. Well, you just simply change it and rerun the statement. It'll drop the table if it's there and rerun this create table as select statement. And then the last one, the profiling log table. This is very useful to say, hey, we think there was a better distribution that we could have picked, but I want to look at what that, what kind of metrics or what does our data actually look like. I don't have to go and create this profiling SQL script. I can simply just open up my log data profile log table and look at, okay, for the call center table, here's the column name, here's the data type, here's the unique value count for that data type, the null count, the min value, the max value, min length, max length, et cetera. All these types of things that we take into consideration when determining what's a good distribution, what would be a good column for an index. All of this is right at your fingertips to say, okay, you know what? We think this other column may be a better candidate. Well, does it have a lot of nulls? Because if it has a lot of nulls, it's going to create a hot distribution, which impacts query performance. So this gives you this view into your data of what was actually staged as part of the process. So then jumping back to the slide deck here. So the log tables, we just walked through the profile table that gets created for you, the auto ingestion table, and then the serverless DDL table. And that's all the features as part of the auto ingestion process. So you can start from ground zero, nothing, to all of a sudden you have a fully functioning data in your dedicated pool, data created, data definitions for your lake database tables, etc. All as part of this metadata-driven process.
And so, if the audience want to kind of find this, it's obviously still sitting in GitHub. Do you have a kind of something that they can search for in the GitHub repo?
Absolutely, Shane. Can you?
Yeah, it's currently in my repository. There's an Azure Synapse Analytics POC repo out there under my account, Shane Okami, but we're soon to move that over into the core Azure.
Cool, nice.
That's the one.
I absolutely love this. I love the fact that we've been able to simplify for customers. I mean, it's a case of like, hey, you can really take this, get yourself up and going. And I think just for those folk that are just learning, getting in as kind of the newbies, there's a lot that you guys have done in taking the decisions. For those that are kind of probably deeply and highly skilled in this area, it's a great accelerator for them to say, all right, we know what's going on under the hood, but I don't need to go and do all the building pieces. It's all built, and I can take that and kind of run it forward. So I think it's definitely hitting all areas. And at least these types of reference architectures are just great ways to kind of get customers moving. Any final parting thoughts from you guys, or before we hand back to Matt? Nope. All righty. Cool.
Okay.
Great job, guys. I mean, that was just awesome. Matt, over to you.
Yeah. Cool. Thanks so much, guys. It's super helpful. I'll get those links in the description. And if anyone has any questions, do feel free to send mail at msusdev@microsoft.com. And come back to learn more about Azure soon. We've always got more. Take care, everybody.
Take care. See ya. Bye.
Thanks. Yeah.